Tells you a little bit about avgas. It tells you it consists of hydrocarbons, so hydrocarbons contain hydrogen and carbon only, no other elements, including a high proportion of hexane, exists as several isomers. Okay, draw the skeletal formula. So remember, a skeletal formula is just a series of lines, and at each corner or at each end there's a carbon. You don't draw the hydrogens on there, and you do it in a zigzag pattern. Draw the skeletal formula of two branched, so the important word is branched isomers of hexane. So hexane's 6 carbons in a line, so you've got to have a branch. So if you have a branch, then you've got to reduce the number of carbons in the main chain. So there could be 5 in a line with one branch. So you could have 5 in a line with a branch. The branch can't be at number 1 or number 5, otherwise there'd be 6 in a line, it'd be hexane. So it could be, the branch could be at number 2, or it could be number 3. So you could have 2-methyl pentane, or you could have 3-methyl pentane. So 2-methyl pentane would look a little bit like the top one. 1, 2, 3, 4, 5. Notice we've got, you can put dots at these points if you want to, but we've got 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5 carbons, and the methyl group there. So that's a carbon there is a methyl group at number 1, 2. So 2-methyl pentane. And this one is 1, 2, 3-methyl pentane. This methyl group going up could also come down. And this one going down could go up. It doesn't really matter which way it is, and a zigzag is the way to show that there's a carbon on each corner. Incidentally, you could have 4 in a line. There's no reason why you can't have 4 in a line, but with it being hexane, 6 carbons, you need 2 branches this time. So I've got 1, 2, 3, 4 carbons there with a branch, a carbon there and a carbon there. So I've got dimethyl butane now, so 4 in a line is butane, dimethyl. I better say where these are. They're at carbons number 2 and number 3, so I've got 2,3 dimethyl butane. And this one, in actual fact, 1, 2, 3, 4, I've got dimethyl butane again, 1, 2, 3, 4. If I start labeling from this end here, so if this is carbon number 1, that ends up as carbon number 2, rather than the other way around, that'd be 1, 2, 3. So at carbon number 2 here, I've got 2,2-dimethyl butane on this one. State the type of isomerism. Well, it's a kind of structural isomerism. Remember, structural isomerism is where the molecular formula, the number of carbons and hydrogens, stay the same, but the structural formula changes. So the molecular formula stays the same, but the structural formula changes, and so the name will change. But there's 3 kinds. So the first kind is positional. The first kind is chain, really. The second kind is positional, and the third kind is functional group. So chain is where you change the length of the chain, so we've clearly done that, so the answer is chain. The other one is positional, where you've just changed the position. Well, you could say here, I've changed the position of this to this one. So these two are positional isomers of each other, but the question is asking, how are these isomers related to hexane? So hexane's got 6 in a line, here's got 5 in a line or 4 in a line, so the branch means that there's fewer carbons in a line, so the chain isomers. Although these two are actually 2-methyl pentane and 3-methyl pentane are actually positional isomers of each other, where the position of the functional group, the methyl group, is changed, and then you can have a functional group change where, I don't know, where the ending changes, where an ane becomes an ene, or an aldehyde, an al becomes an O and a ketone, or something like that. Chain isomerism, because hexane has been changed to give 5 in a line or 4 in a line with branches. Change the length of the carbon chain. But there's 3 different kinds of structural isomer, chain, positional and functional isomer. So you probably could have got away with structural isomerism as well. Safety signs on the fuselage of a helicopter state the air inlets to the engine need to be cleaned out regularly. Write an equation for the combustion. So combustion is a reaction with oxygen, burning, a reaction with oxygen of hexane. So you have to know what hexane is. It's C6. and then you double the number of carbons and add 2, so 6 times 2 is 12, add 2 is 14. So it's C6H14. That would happen in the helicopter if the inlets were partially blocked. In other words, there's not enough oxygen. There's incomplete combustion. Complete combustion makes carbon dioxide and water. Incomplete combustion makes carbon monoxide and water. It can also make carbon and water as well, a black solid carbon. So I think you need C6H14, then you need some oxygen to make carbon monoxide, partially blocked, incomplete combustion, carbon monoxide and water, and then you can balance it. The easiest way to do it, first of all, is realize you've got 6 C's, so you can need 6 C's here, 6 CO's. You've got 14 H's, so you can need 7 H2O's here, because 7 times 2 is 14. Then you add up the number of oxygens. 6 times 1 is 6, 7 times 1 is 7, 6 adds 7 is 13, so you got a number multiplied by 2 that equals 13, that's 6.5. You could incidentally have made carbon here and balanced it instead of carbon monoxide probably as well, but carbon monoxide is usually the gas that's made if something happens, if there's not enough oxygen around to provide complete combustion, and in this case it's called incomplete combustion to make carbon monoxide, an insufficient supply of oxygen, a non-plentiful supply of oxygen. Suggest how the partial blockage might affect the performance of the helicopter engine. Well, it's going to become less efficient. So there's probably various different ways that you can answer this question. Less efficient, needs more fuel to produce the same efficiency, something like that. Less energy given out by the fuel, energy is less powerful or less efficient, yes. It needs to burn more fuel to get the same energy, increased cost due to need more fuel. I think the best answer is energy is less efficient. That's probably the most popular answer.